Welcome to qnawire.
We're given this disk with an angular velocity omega, and we need to find the angle between the angular momentum about the point G of this disk and the axle of the given diagram. So we're essentially going to have to find the equation for the angular momentum about this point G and use that to find the angle that we need. So we'll start the problem by writing the equations for the different components of the moment of inertia. And keep in mind that in this free body diagram, there's going to be no z component of the angular momentum due to the direction that this angular velocity is given. So for the x prime component of the moment of inertia of this disk, this is going to be equal to 1/2 mr squared. And for the y prime direction, we know that this is equal to 1/4 times mr squared. For the angular velocity in the x prime direction, this is equal to omega times the cosine of beta. And for the angular velocity in the y prime direction, this is equal to negative omega times the sine of beta. So now for the x component of the angular momentum, this is just the moment of inertia times the angular velocity. Which we can simplify as mr squared times the cosine of beta. So mr squared times omega times the cosine of beta divided by 2. Now for the y prime component. So it's the moment of inertia times the angular velocity. And we can simplify this as negative mr squared times omega times the sine of beta divided by 4. So now the equation for the angular momentum about the point G, that's equal to the x component. So I'll write it in black. So angular momentum about the point G, that's equal to the x component x component I minus the y component j. So next what we're going to do is we're going to find the angle between this axis x prime and the angular momentum about point G. So I'll call that angle phi. So angle phi, that's going to be equal to the tangent inverse of the y component of the angular momentum divided by the x component. So rewriting that, angle phi, and plugging in those terms, you have the inverse tangent of the y component divided by the x component. So divided by 4 and divided by 2. And we can rewrite this as the tangent inverse of the tangent inverse of the tangent of beta divided by 2. Right, since sine over cosine is equal to tangent, and mr squared and omega will cancel each other out. So now we can substitute 20 for beta to get an angle phi. So angle phi is equal to the tangent inverse of the tangent of 20 divided by 2, and this will give us an angle. And this should be negative tangent. Since we still have this negative sign here, it doesn't get canceled. So we keep this negative sign over here. So this should be negative here. And this will give us an angle of negative 10.3 degrees. So now that we know this angle, we can now find the angle between the angular momentum and the axle. Since angle theta, that angle theta is going to be equal to that angle phi plus the angle beta. So angle theta is equal to negative 10.3 plus 20, and this will give us an angle of 9.7 degrees.